Try-storming is a simulation-based strategy for process improvement. The purpose is to test out many approaches to an issue in a safe setting before deciding on the best one to use in the real world. It's common practice in Lean Six Sigma projects to use try-storming simulations to find and try out potential process enhancements. Organizations can use try-storming simulations to test out potential solutions to problems before committing to any one of them. This can increase the likelihood of a successful rollout by highlighting and removing obstacles. Stakeholders' buy-in and support for the change can be bolstered by try-storming simulations, which allow them to experience the change's potential benefits firsthand. A close examination of try-storming simulations reveals that they can be laborious and costly. Since the simulation is a sterile environment, the results may also not be representative of the real process. When considering whether or not to employ try-storming simulations, the literature on process improvement recommends taking into account the cost-benefit trade-off and planning and designing the simulation properly to get the most out of it. For example, in a product management organization, try-storming simulations may be used to assess potential improvements to the product development process. The simulation could consist of a mock product development project in which team members take on different roles and experiment with various solutions. The purpose of the simulation would be to discover areas for process improvement and to evaluate viable solutions to identified issues. This would allow the business to make informed decisions about how to optimize the product development process and improve its efficiency and effectiveness. Example: ultimately, a manufacturing firm would like to shorten the time it takes to bring a product to market. To achieve this goal, they want to streamline the production process and get rid of any bottlenecks that may arise. The company decides to employ try-storming simulations to identify and evaluate potential solutions. They put up a simulation of the manufacturing process, with team members acting as operators, supervisors, and managers. The simulation entails executing a simulated production run, with the team experimenting with various methods for the process. Several bottlenecks in the process are identified throughout the simulation, including long wait times for raw supplies and slow machine speeds. In addition, they experiment with a variety of potential solutions, such as optimizing the scheduling of raw materials and upgrading machines. Following the simulation, the team evaluates the results to determine the most effective option. Findings show that optimizing the scheduling of raw materials has the greatest influence on cutting lead time. Based on this data, they decide to adopt this method in the actual manufacturing process. Using try-storming simulations, the organization was able to find and evaluate alternative solutions to the problem of extended lead times. This enabled them to make informed judgments on how to optimize the manufacturing process and reduce lead time, thereby boosting their company's efficiency and competitiveness.